Hello and welcome to my C programming series. In this episode, I'm going to talk about arrays and pointers. It's important to know what pointers are. If you don't know what pointers are, I have a dedicated video for pointers. Click on the card and watch that video first. Pointers are pretty much the basics of how array works. Let's jump into Visual Studio and work some examples. What are you doing here? Let's go cycling, Reza. I'm in the middle of a video. Let me do the video first and then we can go. Okay, after the video. The name of the array is actually the pointer to the array. So in this case, let's create a double array 5. So the name array here is the pointer to the array. I can just go ahead and create a pointer and say it's equal to the array example. Let's create double star ptr, let's name it pointer, and then that's equal to array. And as I said, array is address is pointer, so I don't need to put an and% before it. I know it sounds confusing, but pay attention here. The name of the array is basically an integer pointer that points to the beginning of the array. Makes sense, yeah? As I said, the name of the array is the pointer to the beginning of that array. Now, I create a ptr pointer that points to the beginning of that array. It equals to the array, so both are now pointing to the beginning of that array. Let's experiment that. I'll add some printf statements and the address of the first element. So the address of the first element, if I wanted to print it, is I'm going to use %p to print the address. And the first element in the array is array bracket 0. So array bracket 0, this is an integer, and % to that brings us the address to the first integer in the array. Okay, semicolon, and then on the next line I can copy and paste this. The address of the array is, now we know that array itself, as it's just array without any square bracket, it's a pointer pointing to the beginning of the array. And the pointer to the array. And the pointer to the array is, and I would use ptr. Okay, perfect. Just pause the video. Think how different would be the result of these 3 lines. Okay, let's compile and run the code. Okay, so as you can see, the address of the first element is, the address of the array is this, and the pointer to the array is this. All 3 of them are exactly identical. It means that the name array, the pointer which was equal to the array, which is pointing to the array, are pointing to the same position in my memory. All 3 of them are pointing to the same position in the memory, which is the beginning of the array block, which the beginning of that block of memory. Now that we learned about pointers in array, we can manipulate the array using pointers. You remember in the previous video, we used to use brackets and indices in the brackets to access to the elements in an array. We can do the same thing with pointers. Let's get rid of these printfs. Remember I told you, if you wanted to access the third element, you can use the name array, square brackets, inside the square bracket, the index number 2, which you're now accessing to the third element in the array. Now you can set it to whatever you want, for example, 5. You could do the same thing with pointers as well. So just say ptr plus 2 to get to the next two element. Move the pointer on the memory and then dereferencing it. So now you're pointing to the value that is saved on that memory. Now I can set it to 3.4, for example. So let me debug this code. Let me put a breaking point here. And if we start debugging, if I go to the memory address of array and we step over. Okay, so you see that the third 8-byte, which holds the third element, changed to the code for 5. And if I step over, that will change to 3.4. So both these lines are changing the same thing. You see that I'm saying you have to forward 16 bytes, but I have written 2 here. Because I have declared this pointer as double, C would know that by incrementing the memory, I'm moving to the next element, so that 2 means 2 times 8 bytes, which is 16 bytes here. One of the most important use cases of pointers and arrays is that I can send the pointer of an array to a function. So I'm sending the address to the first element of an array to a function. Now in that function, I can modify that array, and that's very important and very useful. I want to write a function that this function logs the array on the screen. Okay, so I'll go ahead, let's get rid of these. And I'll get rid of the pointer as well. I'll declare my function here. Let's name it, the function would be void because it's just printing something on the screen. Array logger, and I'll put a double here so I know that this is for double arrays. And it takes the arguments, a double, a star, a pointer to an array. Let me actually put the ptr array here so I would know this is a pointer. And I actually need to know the size of the array as well, but that would be an integer. Array size. Okay, now we declare the function, let's implement it. Okay, to implement this function, I want a for loop, definitely. I want to have an iterator that starts from 0. We talked about this. And I less than array size in this case. And at each iteration, I wanted to have I++. Inside the for loop, what I wanted to do is I want to print the array on the screen. Print f array %d, and it equals to %lf. The first argument is I, which is the increment, and the second argument is the array, not array, it's ptr array this time. It's ptr array with the index of I. So you see that when I put the index, now I'm referring to that specific index in the memory. That's not a pointer anymore. I'm referring to a double variable actually. Okay, so this should print out my double array, but let me actually use an initializer list to put it to 0, 0, 0, and let me put 5 zeros here. Now I need to call the function on the main function. So array logger double, and in the function array logger double, I need to put the pointer to the array first. So I just put the name of the array, which is the pointer to the array, and then the size of the array, which is 5. And now let's compile and debug the code. Let me actually put a /n here. So I'll go to next line. Okay, awesome. You see that array 0, 1, 2, 3 to 4, and the value is being printed on the screen. So now I want to have another function. In that function, I wanted to initialize the value of the array to 1 instead of 0. So I'll name the function. I don't want the function to return anything. I just want my function to modify an array. I'll name it ones, and I'll indicate double so I would know that this only works in double. Double star PTR array, the same thing, because I need to get an array, and then I need also the size, so these wouldn't change. And I can copy the declaration and paste it here to complete my implementation. I'll use a for loop. The same thing. Iterator starts from 0, goes to the array size, and then iterator is incremented by 1 at each step. And now I would say just pointer array index of I equal to 1. Now if I go to my main function and call this function to my main function and call this function we just wrote, ones double, and the input arguments array and 5, and basically copy paste the array logger here as well, and Control F5 to compile and run the code, you would see that the first batch it's 0, but then the second batch it's 1. So my code is working, and the function takes the array and changes every indices of the array. I wanted to show you something cool with pointers that you can do here. Is you can change the elements in an array, not just using the square brackets and the index in it. You can use the pointer. So I said pointer is pointing to the address of the first element in the array. So if I add I to it, now if I is 0, I'm pointing to the first one. If I is 1, I'm pointing to the second one. If I is 2, I'm pointing to the third one. So now by changing I, this pointer will point to different elements in the array. If I dereferencing it, now I have access to the value of that pointer, that address. Now I can change it to 1. So this code is identical to the previous code I showed you. Let me actually compile and run the code. You see that again, I successfully initialized the array to 1. Let's get a bit crazy in this example. Okay, you remember in the for loop video, I told you that this doesn't have to be integer. This condition doesn't have to be like this. And this iterator doesn't have to be I++. It could be anything. So let me actually do a cool thing. Instead of starting with an integer iterator, I'll create a double pointer. I'll name it PTR. Let the double pointer be the PTR array that we just get from the input in this function. And as long as the PTR array, as long as the PTR is less than PTR array plus the array size. So what is this? PTR array plus the array size. What do I mean by this? This PTR array points to the beginning of the array. Array size is the size of the array. So basically, this is the end of the array. This is pointing to the end of the array. Awesome. And now I can increment the pointer, PTR plus plus. Now, each time, at each increment of the loop, I want you to move the pointer one step ahead. Point to the first double, then point to the second double, then point to the third double until you reach the memory address of the end of the array. Then I don't need to continue. Okay, and here I just need to dereference PTR because PTR is changing at each iteration. It's being incremented until we reach to the end of the array. So if I compile and run this code, you would see this exact same result is appearing on the screen, and the array is initialized to 1. Oh man, this is getting serious. I'm so excited. Okay, thank you guys for watching this video regarding arrays and pointers. If you have any questions, please feel free to comment, text me, or email me. Have a great day and see you in the next video.